Okay, welcome to Accelerated Math. This is word problems evaluate an exponential growth or an exponential decay function. You may have seen some growth or decay formulas like y equals a times 1 plus r to the t, time period up here, rate, and initial amount. Or you may have seen y equals a times 1 minus r to the t power. Okay, so this one over here is a decay, and notice it's got the minus sign in it, so that's a decay function, and this one is of course an exponential growth because it's going up. Okay, A generally stands for the initial amount that you start with, and then T is for the time periods, and R is for the rate, and it's usually expressed in a percentage. Don't worry too much about the formulas because on here they're giving us the formula they want us to use within these problems. So it's just a matter of kind of reading through the word problem and understanding where different things go. As I mentioned, that A value up front is the initial amount, and that's what we got in this formula. So they're going to use all kinds of different variables, but E here stands for the entrance, the number of people that were in this. There was Alicia competed in a chess competition where there were 160 entrants. In each round of the competition, half of the entrants were eliminated. So they matched people up and eliminated half of them. Somebody wins, somebody loses. To find the number of entrants remaining after a round, use the formula, P equals E parentheses 0.5 times R, or raised to the R power, where P is the number of players left, E is the number of entrants, and R is the number of rounds. Okay, and so you can see this rate here, that's 0.5, which is 50%, and what they say 50% of them are going to be going out. So basically this one is just P equals the number of entrants, parentheses 0.5, they gave us that, and the number of rounds they're asking for after 3 rounds. So you're simply going to go to the calculator and plug it in. So we got 160, let me clear what's there. We got 160 entrants times 0.5, and then raised to the third power to say how many are going to be left after 3 rounds, so it's 30. Alright, so we got 30 left after 3 rounds. Wow, I said 30, but it was probably 20. Yes, I don't know where I got the 30 from. So anyway, you knew I was wrong. Alright, so it's 20. Now let's take a look at this next one. Again, they're giving us a formula, and let's see what they say about this word problem. A colony of about 4.5 million bacteria is treated with an experimental antibiotic. Solving real world problems. Every hour, 25% of the bacteria die. Use the formula N equals A, parentheses 1 minus 25 over 100, parentheses T. That's a T up there, can't tell. Where A is the initial number of bacteria and T is the time in hours to estimate the number of bacteria still alive after 10 hours. So we're looking after 10 hours, the initial amount of the bacteria, and 25%. You can look, so N is going to be the number left. We started with 4.5 million. 1 minus, they put in the 25% right here. 1 minus 25 over 100, and we're talking about after 10 hours. So this one, this whole objective is really just a matter of figuring out what to plug in where, and then using the calculator with it. So I was looking for, it might help if I could reset this. Yeah, anyway. Oh, there it is. It's down there. Yes, I want to reset, so I pushed the button. Ugh, and I told it, yes, I want to do that. Enter. Alright, I just wanted a clear screen to work with. So we got 4, 5, 0, 0, 0, 0, 0. That's, wow. That was way too many zeros. 4, 5, 0, 0, 1, 2, 3. Okay, 4.5 million. Parentheses. When you do that in the calculator, it already knows it's going to be multiplication. 1 minus 25. I'm going to hit the fraction key to throw that fraction in there. Over 100. I could have also put that as 0.25 or 25 and hit the percent key afterwards. Close those parentheses, raise it to the 10th power. After 10 hours, I'm going to have 253,410. 253, 410 and some change. Okay, that's how many bacteria I'm going to have left. And they wanted an estimate after those 10 hours. So that's it. All right, next one. Jahan invests $2,000 savings account, yields 3.5% interest compounded annually, compounded once per year. And they're going to give us the formula anyway, where C is the amount invested. So we're going C is the amount invested, 2,000, 1 plus 3.5 over 100. That's the 3.5%. And to the T power, and they're asking for what's it worth after 8 years. So 8 is going to go into T. T is this one up here. All right, so 8 right there. So it's just a matter of going to the calculator and $2,000. So 2,000 parentheses 1 plus, I could put in the 3.5 over 100. I did want to show you this. I could put in 3.5 and hit the percent key as well. That was second and this open parentheses. So that's another way of doing it. And then raising it to the 8th power. Another way to do it is 2,000 and 1 plus, well, 3.5% is 0.035 as a decimal, and raise that to the 8th power. And I still get the same number, so 263, or I could have entered it the way they had it here. So it was 263, rounded up, 2634. All right, one more. And I wanted to show you this one because it's a little bit different. They're talking about the price of 5 pounds of flour. Well, don't get confused. You're not using the number 5 in here. This could have said the price of a calculator, the price of a hot tub, the price of a, whatever it is. So it's just 5 pounds of flour. It's just a product. Okay, so the price of this package of flour generally increases by that percent. You can see they have that percent listed there each year. The change in the price of 5 pounds of flour is modeled by this formula, where P is the current price. Okay, watch out for that one, because this one we're going to put the current price, and they're going to tell us what the current price is. So here's the $3.20. That's the current price. So this one a little bit different, 3.2 equals C times 1 plus 2.5%, and to the T power. They want to know how much it would this flour have cost 10 years ago. So I put a 10 there, and this is going to work backwards. This is today's price. C represents the cost T years ago, or X number of years ago. All right, so we're going to work backwards with this. You can do it two ways. You can do all this with your calculator, and then you're going to divide both sides by that number. I'm going to choose to just show you in the calculator where I'm going to divide it by this. I don't even really have to write this down, but I want to make sure you see what I'm doing. And I'm going to divide this side by that same thing, 1 plus 2.5 over 100 raised to the 10th power. These two are canceling out, or reducing to 1. So it's just left with C equals, and that's what we need to put in the calculator. And it's a little bit, let's see, come on calculator, but I need to move you over here. All right, clear that. And we're going to go 3.2. We're going to put it in a fraction. I'm going to do parentheses 1 plus 2.5. And the cool thing about these calculators, I can drop another fraction inside here and get out of here, close those parentheses, raise that to the 10th power. And that's exactly what I was looking for. 3.2 divided by all that mess. Do that, 2.499. Let's call it probably 2.5 or $2.50. There it is. All right. Have fun with it. Make sure you got your calculator.